My name is Randy Mayberry. I am a solutions consultant for the manufacturing division. I am coming to you from close to Raleigh, North Carolina. So today we're going to talk about automating processes with iLogic. Quite often on these iLogic webinars or webcasts, we talk about ways of configuring components or assemblies or something like that. This is a little bit different kind of view on that. Other things that we can do with iLogic that assist in those processes, not necessarily configuring something. And looking at my photo there, I do think we need to do an updated there. My hair is a lot longer and a lot grayer these days. I think that's from working with Carl. So topics we're going to go over today. Working with parameters. We're going to talk about creating parameters, exporting parameters, building parameters from an Excel spreadsheet. We're going to talk about adding attributes, discuss a little bit about what attributes are, as well as the new name geometries that was introduced in Inventor 2019 and how those kind of work with attributes as well. Look at some other ways of generating iPart or iAssembly children, a different method for doing that with iLogic code. Traversing assemblies, typically or quite often, we need to work with something in an assembly and we need to modify or touch every single component inside of our assembly, and maybe pass some iProperty information to it, or change some information about it, or export all the flat patterns that are in there. So we'll look at code for traversing assemblies and doing that kind of work. And oldie but a goodie is exporting bill of materials. Quite often we need to export that BOM or that bill of materials out of an assembly, and then format it in a way that works for us, whether or not I'm sucking that into some other type of system to build inside maybe my ERP or MRP system, or just formatting it the way your company wants that bill of materials to look. And all of the iLogic rules that I talk about today can be made available through your account manager. Okay, so the first topic we're going to talk about here is working with parameters. So we'll look at code for building parameters inside of either a part, assembly, or a drawing. It really doesn't matter. The code will work for all. And some of the reasons we might want to do that, as opposed to just opening up our parameters dialog box and start typing, is organization. I like to organize my parameters based upon kind of a category. So if I'm doing a project, quite often there's job information, right? There's dimensional information. There might be data that only has to be used for iProperties. So I will build those inside of Excel. I've got a little template that I use, and I type out all the names. I make sure everything's situated in the areas that I like. And then I'll read that Excel file and create those parameters inside of the active document. So we can do both creating parameters this way, and then we can also export parameters this way. So if you look at my little image over there, I've got some parameters that are shown, and that's what we're going to create with the code. So I'm going to switch over to Inventor here real quick. And I've got a part here open. There's nothing inside of it. There are no parameters inside of it. Let me pull that guy over to this window. So we're talking about a completely empty parameter part here. And I am also going to open up the Excel spreadsheet here to show that to you. So I've got them listed in certain orders. I've got my parameter name, what the unit of measure is, what the expression would end up being, and then as well as the is key. The comments, I don't have anything listed right here, but I do have some information in there if I wanted to add some comments with a delimiter. There is some Excel magic going on inside of here. Again, so I've got these sort of separated by information about the job, specifics about maybe the particular assembly that I'm building here. So I'm going to go ahead and close that, come back to Inventor, and I'm simply going to launch that create from Excel rule. This is asking me where is the Excel file that I'm using. Okay, I'm simply going to select that parameter creation Excel file we just chose. Hit open. And it's asking me which row has my column names. Maybe, I'm actually starting data on row 6 or row 7. I keep this in here for the rules that I use all the time. If you had a specific method for building yours and you knew it was always going to start on maybe row 2 or row 3, you could hard code that as well. And wouldn't you know it? Bear with me just a second here. I'm going to switch over to that guy. There we go. Row complete. Open up my parameters dialog box, and there they are all listed. So depending on the unit type, it has to set certain values as it's building through. And we'll take a look at the code, but I've got some listed there as strings, some are listed as inches, some booleans, and then notice that they're all currently marked as key because I had true set on all of those. Right, so let's take a look at that code. I'm going to edit this rule and pull this window over here. I tried to size this large enough so we wouldn't have too much of a difficulty in seeing the text. I'm not going to go through line by line, but I want to touch base on all of what this code is doing so you have a better understanding of what's happening there, right? So up at the top, I'm simply doing some declarations. I'm declaring that the document is an object. I'm doing that so I can check what style it is. So right here in this conditional block, drawing parameters are in a different section of the API than assemblies or parts. So really that's the only reason I'm making a check here. So I'm setting my user parameters based upon what kind of document type we're looking at. Okay. Here in this Excel file selection, I am throwing up a dialog box, allowing the user to select what Excel file you want to read data in from. Okay, so I'm setting a filter for it, I'm setting the title of it, and then I'm setting the initial directory. And this directory is simply where I know that that file is for this webcast, right? That just makes it easy. Once the user has selected, I'm storing that data in this parameter called Excel file. I'm throwing up an input box here, again, asking what row has the column names. So again, if we knew that I'm always starting on 2, I wouldn't necessarily need all this, and I could simply set my header row to whatever value I know that is. Then I'm setting my row, my I row, where I'm actually reading in data as header row +1. Right, I'm going to start at that area. Then I'm looping through all of the columns here and getting information about that column. So I've simply chosen a value here of 200. We could always loop through and look at the first time we find an empty column. As a matter of fact, I'm doing that a little bit later on here. But I'm simply going through and saying, okay, in column 1, here's what my cell value data is. In column 2, here's what my cell value data is, 3 at 4. Okay, so it's reading that using the iLogic Go Excel function, right? There is a whole section inside of the iLogic snippets here called Excel data links, and that's what I'm using here. I'm using the cell value. Okay, in this case, I'm reading that and I'm storing that value somewhere. So I'm storing it in the cell contents. Okay, so now I know what all my column names are. Now I'm going to loop through each row listed on there and then read in that data. So this for each loop here for my J variable is going from that I row number up to 10,000. Again, I just randomly chose a number there. I look at the cell value. If it's empty, then I'm exiting out of this loop. So if we get to the end, if I get to, let's say row 200, and there's nothing there, I know there's no more rows inside of that Excel sheet. So I'm jumping out of my loop and finishing on with the rest of my code. Okay. So then I store some data here, right? My parameter type is reading the unit of measure column header for the current row that I'm on. Then my expression is reading the expression. My comment reads the comment column, and then my is key is storing that is key column. And then I throw that data out to a trace write line here. A few versions ago, I think it was 2018, we have the logger now inside of iLogic. I do like that tool. It is included inside of iLogic. I also throw quite often stuff out to the trace write line and read it with a debug view. It's just my go-to. So that data is just getting thrown out to some separate entity, separate program, so I can see what's going on. And here's where we're actually doing the meat of what's happening here. So in my user params, I'm either adding by value, the add by expression method, or the add by value, based upon what that parameter type is. So it's different arguments that are required. It's a different method, right? So here I'm doing the add by value. Here I'm doing the add by expression, based upon, is this a text? Is this inch? Is this UL? And this is reading off of that Excel spreadsheet, right? Understands what type I'm looking for there. If the comment is not blank, then I go ahead and create that property. Okay, and then again, I'm throwing out just a success here for, and we go to the next row, right? I'm looping that J there. So then I'm moving down to the next row, the next row, the next row, again, until I'm blank. Okay. Then I update my document. I use the goexcel.close to close my Excel connection there. And then I'm throwing up that message box. Okay. This rule also has a function down here for convert to letter, because I'm counting those columns as numbers, and this is converting those to a alphanumeric. So if you pass it a 1, it's going to pass back an A. If you pass it a 3, it passes back a C. Okay. The Excel wants to see things in those letters. I'm counting by numbers, so this is just doing a small conversion there for me. Okay, and that convert to letter is happening right up here. Okay. So nothing too fancy there. Again, the major portion of the code that's doing the heavy lifting is right here where I'm adding those various types. Okay, so I'm going to close that. And again, we've got these parameters in here now. So another tool that I can do here is export parameters. So I'm going to go ahead and run my second rule here called export. I'm going to select a spreadsheet that's sitting out there. My rule is complete. Simple enough. Oh, wrong folder. And there's my param export. I will launch it. And there we go. So I've got names, the unit of measure, the expression value. I'm also spitting out model value here, right? So we can export whatever fields out of that parameter dialog box that we want to. So I'm gonna go ahead and close that. We'll take a quick peek at this one. This one works a lot like the create. Right? I'm still doing the same stuff up top here. I'm still throwing a file dialog up here, allowing the user to make a selection. Then I go open that Excel file with the goexcel.open. And then I actually write those column headers out. So the Excel file that I chose there was blank. right? So I'm still using the cell value function of GoExcel, but since it's on the left-hand side of that equal sign, I'm writing that data out. So A1 becomes name, B1 becomes unit of measure, C1 becomes expression, and so on and so forth. And then I'm looping through all of my user parameters. So I'm not writing model parameters here. I'm writing user parameters, but we could easily change that and be looking at model parameters, of course. And then I'm looping through. So A2 in this case becomes the user parameter name. B2 becomes the units. C2 becomes the expression. Then the value. Then the model value, if there is a model value. So if it's an inch or it's a degree or it's a unitless parameter, we would have the model value. Same thing with the is key, and then the same thing with the comment there. Okay, and then I'm just, again, looping back through every single one that's in there. GoExcel save, so I am saving this one because I'm writing out to it, and then I'm closing that Excel file. And then again, showing up that dialog box, or that message box, I'm sorry, just to say that I'm done. Okay, so let's close that. I'm going to jump back to here. We're going to talk about adding attributes. So attributes allow us to get faces, edges, work features, etc. Inside of automation. So if you see in the image that I show there, each one of those faces has a attribute tied to it, and they're just numbered face 1 through face 6 there. And we use those when we're trying to select that face again programmatically. Okay, so faces or edges, quite often using for constraints or for dimensions, right? So anytime that you, as you're using Inventor, I make a selection on a face or an edge, well, how would I go about that programmatically? It's with attributes. Name geometry, which again was introduced in Inventor 2019, it's a friendlier method of using attributes. Okay. Prior to that, or if you actually want to use the attributes, you have to do it, create them either programmatically, or there are some tools out there that allow you to do it through a small little user interface as well. And in 2019, they gave us the named entities, which allows me to select a face and assign a name to it. That actually creates an attribute, and it's written in a very specific way. So we'll look at code that creates both attributes and then code that creates name geometry as well. So let's take a peek at Inventor here. So here's that same piece that we saw in the image there. I'm going to run my create attributes rule here. It's not going to be very exciting. It went and did stuff. So I'm going to hit OK to my dialog box there, and I am going to launch a tool here called Nifty Attributes that allows me to look at these. So there is a face that has an attribute now tied to it called face 1, and it's highlighted out there in my window, right? There's face 2. There's face 3 is the bottom. I've also accessed or added attributes to origin planes here. So I've created one called YZ, one called XZ, one called XY. Again, why would we do this? If I need to constrain this component inside of an assembly, I can use these attributes to find those faces, to find the edges or find those work planes and then work with them. Say I wanted to color one of the faces differently. I could always find that face that way and then programmatically change its appearance. So if I hit OK here, I am going to go ahead and open and edit this rule. So again, we're creating attributes here. I'm declaring some stuff up at the top, work planes and faces. That's all I'm building in this small example. So the first thing I'm going to do here is look at my faces. So I'm going to loop through all of the faces that are in my current surface body. Okay, so 1 to whatever the count there is. In this case, it was 6, right? That box has 6 faces. So I'm setting what I want that attribute value to be here. So I'm simply doing a concatenation there of the word face with an underbar and then whatever I happen to be at, right? I'm looping through all of these, so it's going to be 1, 2, 3, 4, 5, 6. I'm setting the attributes on that particular face, right? So face 1 in this case, the first time through my loop. If it's already got an attribute attached to that with the same value, I'm going to go ahead and delete it. I'm making the assumption here that, hey, if I've already created face 1 in this face, I'm just going to delete it and recreate it again. And then I'm actually adding it right here. So my attributes.add method, that new value. Right? And again, I just loop back through all of them. Then the same thing with work planes. Okay, I'm simply working with the origin planes here, but I could work with, any kind of work plane that happened to be created or any kind of work axis. Just have to be looking at the proper collection. So in this case, I'm going through the work planes count. If the plane name is XZ, I'm making the XZ name for my attribute, the YZ name, or the XY plane. Okay. Does the same thing down here at the bottom. If I've got an attribute already tied to that plane with that same value, I delete it and then I recreate it. Okay. It's a little more exciting to see the named attributes. Actually, let me go back to this guy. Right. So I think it was 2018. If I select a face or an edge and I right click, I have an option in my contextual menu here called assign name. Okay. And that's the way I can call this, face top. If I create named geometry, I actually get a new tab here in my iLogic browser called geometry. And it will list all of the geometry that's out there. I can change the visibility of that label. I can rename it, or I can delete that. Okay. Again, a named entity is an attribute that's just labeled specifically. So if I take a look at this face here, remember I created some attributes here before. This one also has a new one called the iLogic entity name set. And then it's got an iLogic entity name with that value that I entered. Okay. In the end, it's the same thing. I can still grab them all programmatically. I can work with them. It's just, again, the name geometry is they expose through the interface of Inventor here, so I can work with it as opposed to having to do it with code. Okay. So if I jump over to another part here, and I'm going to run my create name geometry rule. And here we'll actually see those because I'm not creating the attribute, I'm creating the name geometry. Again, I'm looping through all of the faces on this component and adding that named entity. So anytime, I'm going to jump over here and add a rule. Turn my snippets back on. Right, so these relationships that were in Inventor 2021, I do believe, right? This new category over here that allows me to, for example, add a mate constraint. These entity names that it's looking for right here, right? Those could be named geometry. If I let Inventor add them, it creates them. It uses what I think is not a very friendly naming scheme. That's why I like to create them on my own. Okay, so I'm gonna go ahead and close that. Then we'll take a look at that named geometry rule. It's much simpler, not a whole lot to this one. Again, I'm making some declarations up here at the top. I'm getting the named entities from that document. And then the same thing here, I'm looping through all of the faces. I'm setting a value of what I want that name to be. And this is simply the set name function of the named geometries object. So against that face, I want you to create something with this name. Okay. Let me jump back to Excel. We'll look at generating iParts or iAssembly children. This is rules that we would run from the factory, right? You've got that iPart factory that controls and can create all of those children. We would want to run this rule from our factory. It's going to build all the children that are in that table. Okay. It's not necessarily any quicker than manually generating those files, but it's much easier. I don't have to select all of them, right click, choose generate files. I don't have to worry about what view I'm looking at there in my model browser. And if you loop it or use it in conjunction with other batching tools, I could generate, all of the iPart children of all the factories, say, that are in a particular directory. Okay, that's a much quicker process than having to do it manually. So let's take a look at that. So this is a very simple inch cap screw, and we'll take a look at here at my folder. I do not have the children already created, right? Here's the part that we're looking at. I've got some of the enclosure pieces done, but I don't have that cap screw done. So I'm simply going to right click and run my rule again. I did throw up a progress bar on this just so you can see where we're at or how far along the rule is. Things like this that run a while, something that I can easily count. I like to throw something like that up so the end user knows what's going on or what's happening there. So we're complete there. I'll go take a look at that folder again, and then it's generated all of those children for me, right? So again, not a whole lot quicker than if I listed this by member name, right? I can select multiples over here, right click and choose generate files. And in essence, that's what I'm doing with the code. But it's just easier for me. Right? So let's take a quick look at that rule. So again, I'm doing some declarations up here at the top. If it's an assembly document and it's not a assembly, iAssembly, it's not a factory, then I'm exiting the rule. So if you're in a document that's not an iPart or that's not an iAssembly factory, I'm just going to get out of it. Okay, I'm just exiting that subroutine right there. I'm setting up my progress bar here. Okay, so what's the message that I want? How many steps? I am setting my steps to the number of rows that are in that factory, right? So if there was 20, the overall total should be 20. And then each time I increment to the next one, it's just incrementing that little progress bar that runs across there. Okay, and this is very simple here. Again, I'm looping through each row in my factory table, and then I'm creating that member. That's the same thing as we see earlier of right-clicking and choosing generate files. And then I'm updating the progress bar. Once it's done, it's looped through all of those rows. I close the progress bar. I, again, throw up a message box there that says we're done with it. Okay, so that same rule will work for both assemblies or parts, or iParts or iAssemblies. Let me put it that way. So maybe right click and run this here. There's not as many of this guy in there, I don't think. So this is an iAssembly made up of iParts, right? And then there's my various enclosures. We'll open up a couple of those. Right, so there's one, just a smaller box, not as wide, etc. Okay. Alrighty. Go back to PowerPoint. We're going to look at traversing an assembly. Again, sometimes we need to, quote, modify all of the components inside of an assembly. I say, quote, modify because maybe we're just modifying an iProperty inside of there, or maybe I need to open that document and do something with it, or maybe I just need to export a flat pattern out of it if it's a sheet metal component, right? So we do what's called traversing that assembly, and those components in this case can either be a part or a subassembly that's in my top level assembly. Okay, so the method that we're going to take here allows me to access assemblies that are inside of my assembly as well. So again, why would I might be doing this? Exporting flat patterns, modifying iProperties, changing materials. The example we're going to see is just going to be modifying iProperties of every component inside of this assembly. Now, if we're looking at, or we don't need to worry about assemblies, and we just want to worry about the lowest level components, the parts, then we can look at something differently. But in this case, I need to modify that assembly as well. So here's an example that's got many subassemblies over here on the left, right? Inside of some of those are components. Some of the other ones have components and subassemblies in them, right? So it's quite the nested overall assembly. And what we're going to do here on this one, I'm going to take a look at the rule first so we can see what's happening. I want to push a sales order number to every single component inside of here, with the exception of content center parts. I'm making the assumption here that if it's a content center part, I don't need to worry about modifying it because that's a standard component. Okay. So I am declaring my sales order number up top here just as some string value. I'm declaring a list of components that I've already processed. That way I keep track of what I've touched and what I've modified. If a part or an assembly is used multiple times throughout the tree structure, I don't want to take the time to look at it again, right? I say, oh, I've already modified you. I'm going to skip you for the time being. Okay. So if our assembly is if our document is an assembly document, then I'm going to call this traverse assembly subroutine. Okay. So what that subroutine does is that runs immediately. That's listed down below here. It's going to look at every occurrence inside of the occurrences of this assembly. So those occurrences are all of the parts or first level components inside that assembly. So if I scroll this over a little bit, I'm going to go look at this first guy, the 018-1031. Do some checks against that. If it's a suppressed component, I don't want to do anything with it. I'm going to skip it. If it's a part document and also a content center member, again, I'm skipping that too. Okay, making an assumption there, that's probably a standard component. I don't have to worry about doing anything with it. I'm getting the file name out of that document. And then I'm getting some the iProperty set here for the custom iProperties. The Inventor user-defined properties is my custom properties. I try to see, is there one called sales order number? If there is, fine. I just modify its value to whatever I want it to be. If there isn't an iProperty called sales order number, then I create that iProperty. And then again, I set its value to what I need it to be here. Then I add that file name of that document to my components process list. If that occurrence is an assembly document, then I call the traverse assembly against that document. So let me scroll down a little bit here. You can see up here at the top, there's my my model tab of my rules editor. We've jumped into this occurrence. We've modified his sales order number iProperty. Since he's an assembly, I'm going to start looking at all of his children now. Once I'm done with all of the children of that, I'm going to move on to the next one. Right? In this case, I'm not going to do anything with the 2 or the 3 or the 4 because that component's already processed. Okay, so I come back up here toward the top. I'm starting and stopping a stopwatch here. I started it at the top of my rule. I'm stopping it down here below just so I can see how long it takes this thing to run. Again, I'm throwing that out to my debug view here, my elapsed time. Okay, so I'm going to save this rule. I'm going to close it. I'm going to run that rule. I think this takes about 17 seconds for an assembly that's got 3,624 occurrences. So there, we're done. And if we take a look at my debug view here, we can see that I'm skipping, right? These are all content center components. I'm also skipping other things because I've already processed those, right? This is just what those trace write lines are pushing out. So if I take a look at my bill of materials here now, pull this window over, and I can add a custom property called sales order number. Right, so that subassembly's got the sales order number. If I expand him, the children have those as well. If I come down here to look at some of these content center components, right, it didn't push those, we skipped those. Okay, I'm gonna go ahead and close that. So again, traversing the assembly allows me to look at subassemblies inside of the top level, as well as all of the part files. If you want to just look at those lower levels, you would want to look at the leaf occurrences. We were looking at all component occurrences, and that would basically treat it like if I was set on part priority of my selections, right? You may be more familiar with using the selection filter up top here. If I choose part priority, I can't select subassemblies, right? I'm going down to the very lowest level component, even though that might be, you know, level 6 of my overall bill of materials. That's what those leaf occurrences are. Okay. Let me switch back. Let's look at exporting bill of materials. So why would we want to do this with code? I can format this any way I want it to. I can pull any kind of data that I want to, not necessarily just data shown on my bill of materials dialog box. Okay. Kind of what we were just seeing there on that assembly. If I use the export tools inside of Inventor, it's going to give me the fields that are shown on my bill of materials dialog box. And I can do this for structured, or I can do this for parts only bills, however I want to or whatever I want to export there. So I'm going to jump back over here, and I'm going to right click and choose Run Rule on my an advanced export rule. Pop open my let that run for a sec. Oh. I probably should have put a progress bar on this one. It seems like it's taken a while. Well, while that's running, we can take a look at the code. Okay, so here's that advanced export bill of materials rule. Again, we're checking to make sure that this is an assembly. Right? Parts don't have bill of materials. If it tries to set the assembly document as an assembly and it fails, then Inventor knows, hey, this is not an assembly. So again, I'm just getting out of that rule. Okay, setting my path, where do I want to store that data at? And bill of materials have two different views for them, right? They've got the structured bill or they've got a parts only bill. I'm gonna hit OK there and it's gonna launch that for me. Take a peek at that. Okay, so I've got this, again, formatted the way I want. I'm pulling out the data that I want. I've got some job numbers, how I want the fields to look, this PM code that's over here, etc. Pop open my bill of materials here. If you're not all that familiar with how bill of materials in Inventor works, we have the structured bill of materials, and then we have a parts only bill of materials, right? So depending on how I want to call this out here, in this case, when we just ran it, I'm looking at the structured bill. And then down below, I am enabling that structured bill. I've got the parts only lines in here as well. We would have to comment those out. Right? We could switch these, comment the structured and uncomment the parts only, and then the same thing with these. If we would want to run it again then and export the parts only bill of materials. Okay, so I'm getting some data about this. The part number, I'm setting what BOM template I want to use, right? I've already got that bill of materials template set up the way I want it. I've got those headers in there. I've got it formatted the way I want it to look. So I'm simply doing a file copy here. So I'm copying the Excel template to a new job name. So I'm making a copy of that Excel file. And then I'm going and opening it up. And then calling again here a function called the query the BOM row properties, which is simply going through every row of my bill of materials. Okay. Again, a loop here, the for I loop from 1 to the BOM rows count, the total. And for each row, I'm getting out whatever data I want for it. So I want the part number, I want the description, I want the PM code, and then I'm writing that data down here toward the bottom. Same thing we saw before with the traverse assembly. If this row has children, then I'm calling it recursively again. Let's look at the children of that row. If not, we just continue on with the next row in the bill of materials. Here again, I'm checking for content center parts. If it doesn't have a content center, or if it is a content center part, I'm setting it to that U value. Okay, that's just my purchase manufactured code that I had listed in there. Once I'm done with all that, again, I do a little bit more writing to that Excel file here, and then do a save, and then a close. And then again, a little dialog box there. And then I'm launching Excel, just so that Excel file that we just spit out opens back up there for me. Okay, let me go back to PowerPoint there. And that was it. So again, if you want to reach out to your Imagine account manager, we can make these rules, these iLogic rules, available to you. I can zip them up and then get them sent out that way. The files, there's nothing special about the files other than this assembly had some stuff in it, but the rules are written to run against anything there, right? I can add the parameters to whatever, I can create attributes or whatever. So that was it for the demonstration section.